Okay, guys, I can see a few guys are back here. So we'll just wait for another minute until 12:10 and then we'll get started further. So I hope that everybody will be back by that time. Okay, so it's 12:10, guys. I can see some of you are back. Let's get started further. Let's not delay anything further here. So the next thing which we'll be talking about is how we can control a task by defining loops and conditions. That is what we are going to study next. So I hope you guys can hear me. And let's get started. Now, first we will be talking about how we can define a condition, right? So let's say if I open any playbook which I have created, let's not gather any facts. Let me just put a simple task over here. Ping and, name, pinging a host, iOS underscore command, iOS underscore ping actually, and destination which I want to ping is 172.25.250.254. Now, I want to run this task when something happens. So what kind of conditionals are available for us to define? So the way we can define a condition is by using the when keyword over here, which is, sorry, the when attribute over here, and the when is the module, it's a task level attribute. So that's why we are defining it on the task level, where the module is what we define. Now, talking about the types of conditions which we have available. So, by default, we do have four types of conditions, though this course covers less than that, so we'll not rely on that. We'll study all the four types of conditions here. The first type of condition is a Boolean condition. Those are simple true and false based conditions. You can define true, false, yes or y, or no or n. We generally rely on true and false. We do not define yes, no, y, n, something. The second type of condition is arithmetic type of conditions, which are generally all about, the greater than, less than, greater than equals to, less than equals to, equals to, not equals to. Yep. Then there is a is based condition, which works on two things. One is the variable definition. And second is, so variable definitions are two, defined or undefined. Do not worry, I will explain you all of these practically. Right now, I'm just making a note so that I can reference it back when I demonstrate it to you. And second is the task status. Task status is succeeded, skipped, failed, and even changed. Now, currently we are using Ansible 2.5, so I'm not really sure if the skipped task status was available back then, right? But all three were there, succeeded, failed, and changed. Skipped was introduced, I think, somewhere around in 2.7 or something, but I'm giving you the latest information, what currently works. And the last one is in, which is to search something inside something else, or maybe, some other list, some list, I would say. Now, these are the four types of condition. Now we have to learn them how we can implement it. So let me go ahead and explain with the Boolean one. Remember, for Ansible, at the end of the day, what matters is either a true value or a false value. Whatever calculation it has to do, if it has to do, but at the end, if the conditional result is true, the task will run. If the conditional result is false, the task will skip. Remember, the task will skip and not fail. So if I say true, which is a hard-coded true, this is generally for only a demonstration purpose, the task will run successfully because the condition is true, means run the task. But if I define a condition as false, which is a Boolean based condition, the task will skip. Remember, in this case, only the condition is being looked, and depending on the conditional result, then the task will be evaluated further. The conditional result is false, that means a simple thing, that you do not even have to run the task. Does this make sense?
Yes.
Great. Next, we will go with the arithmetic-based conditions now. Okay. Now, arithmetic-based conditions are generally relied on the variables. Means if you want to verify if some data is stored somewhere. Okay. Generally, we rely on facts. In this case, so Ansible-m iOS underscore facts for iOS device, and I'll get the output in the less format. So means, page by page output. I'll show you both arithmetic based condition in the form of number and in the form of a string. So for example, run the task if the host name is CS01. Okay. So I have copied the variable name. So if this variable name has the data CS01, run the task. But this variable will only come if we gather the facts up in advance. So we also have to put gathering facts task where I have to define iOS underscore facts as a module, and done. So we will gather the facts once these variables are loaded in the memory. If you remember, they're self-registered data. We will be able to verify this. Remember, whenever you define a condition where you are evaluating with some data, the left side will always be a variable. The right side can be a string, can be a number, can be another variable. But the left side, where you are evaluating from, is always a variable. Save it and run the playbook once again. There we go. So as you can see, the first task is running, the second task is running. What if I want to check if the host name is CS011? Now, if it is not CS011, in that case, what will happen? The task will skip. And you can notice the task is getting skipped. Does this make sense, guys?
Can you show the playbook once again?
Why not? I can. There you go. This is the playbook. It doesn't. That's why we are gathering facts. If you remember, when we gather the facts, it gathers this information as well for CS01. If you will notice, one of the variable in this is about the host name right here in the facts. Does this make sense, any? And if you have noticed, I have put this task as the first task to gather the facts. And these facts are registered in the memory of your control node. So that is how Ansible is able to verify. See, what I'm trying to say is, if you want to match with a fact which is coming from facts, then yes, you need to gather the data first. But let's think of another scenario. What if I hard code this value? For example, let's say vars iOS underscore host in is C01. So now I don't need facts because I have hard coded the information. Okay. So this time I can verify with the variable which I have defined, which is iOS underscore host to verify with C01. So if this variable has this data, run the task. Does this variable has this data? Yes. So Ansible will simply run the task. If you will notice, it is running successfully. But in my previous task, I was taking a variable which was gathered by facts. So yes, I need to gather the facts first in my playbook, only then I can run the task. Does this make sense?
Yes.
No problem. Sorry? As I mentioned before, if you have remembered, we do have other fact modules as well. Grep OS underscore facts. It depends on the OS. What do you have on an OS? So let's say if you're talking about Cisco ASA, right? So which operating system is on ASA? It is iOS only, right? Hello? So that's where you are going to use Cisco iOS. So it depends on the OS. Over here, as you can see, we have this particular set of modules. But if you let me share you my physical machines console here, which is having the latest version of Ansible. Let me share you that first. So this is my physical machines console. As you will notice, I have the latest version of Ansible available, which is 2.9.23. And over here, I will have Ansible-top-l grep OS packs. So here I might have more than that. Right? So the new versions of the OS are coming up with more facts. And even in the future versions of Ansible, you will end up having what do we call more modules to gather facts from diverse background of operating system. Does it make any sense? No problem. So once this is done, what next? Okay. So we have discussed about two of the facts, two of the conditionals so far, arithmetic and Boolean. Let's talk about is first. In the playbook, rather than let's say defining this, I would like to define an IP 17 with a 172.5.250.254, and rather than defining the IP address manually, I will be calling the variable over here, which is this. Now, I want to run this task only when IP is defined. So IP is a variable, as I said. IP is defined. So it is checking in the memory if IP is loaded from anywhere, because it is
And it
loaded
could
from.
be any way we can declare the variables, right? All the previous methods that we showed.
Exactly. That's what I'm trying to say. Variables can be declared anywhere, but for the task, you can put a condition only over here.
Yep.
Right? So Ansible is not checking from where IP variable is coming from. It is just checking if this variable is defined in the memory or not. That is all Ansible is checking.
Makes sense. Yep.
Questions so far, guys, other than this? Okay, let's go on to the next one then. The next type of a condition over here will going to be the task status, which is based on some other task. So let's say a playbook. First, I will register this task, which will also register the status of the task, and taking backup. iOS underscore config, backup to be true. Take the backup only when out is succeeded. Out is succeeded. So out is this variable which I'm storing over here. So if the status of this task is succeeded, means if this task runs successfully, only then this task should run. Take a look. First task ran successfully, that is why only the second task is running. Does this make sense? The task status? Guys?
Yes, yes, yes.
Yes.
Okay. Then one last one, which is in, is to it is not in the PDF, not all of them, but if you want to see just the reference which I'm covering right now, you can look at the page number 93 in the PDF. The book has only one or two types of conditions. They all are not there, but Ansible supports these many conditions which are not explained in the book. So that's why I am writing it on the board for you. I'm explaining this to you, and then I'll send it as an email to you guys as well, so that you have the latest material, which is not even there in the book. Yeah, but for a reference, a couple of conditions are there on page number 93, but everything which I'm explaining is not in the book. I'm just trying to give you my personal experience, which I have had working for customers, creating playbooks for customers. So you guys can, go back to your job and immediately start implementing things rather than learning more. I'm giving you my experience over here. I hope that will really help. But again, that's completely up to you guys. Okay, any questions so far, guys?
No.
Okay, so then we'll talk about the last type of condition is about in, which is to search a keyword inside a list. Okay, so if I will explain it, let me show you the condition which I'm going to make. So first of all, I'll use the magic variable called inventory underscore hostname. So if I run a playbook on CS01 and define inventory underscore hostname as a variable where some data is stored, if you remember, a magic variable inventory hostname stores the target host. The target host is CS01. As you might notice, the target host is CS01. And this is the part of a group called, a lot of them actually. CS01 is a part of iOS group, it is a part of cloud services group, and it is a part of network group. So if I say, if inventory hostname is a part of iOS group, how do I get it? Groups, and the next level is iOS. Only then it should work. Right? So the way I will define a condition is run this task when inventory underscore hostname means CS01 is stored inside groups.prod. So this way we are going to create a condition. Oh, my bad. Prod is not a group, right? So groups.ios. There we go. So if C01 is a part of iOS group, it will run the job. There you go. And the job's running. Does this make sense? Is this understandable, guys?
Yes, yes.
Okay, great. Yes, please. There you go. Yeah, there you go. Do you mean something like try this task? If it doesn't work, catch to this task. Something like that, the try catch functionality from we do have it actually, and we can implement it with block rescue always. So you can put a series of tasks in a block. If any of those tasks fails, you have another section called rescue, which tasks will start running to rescue your block tasks. If anything fails, it happens only on the status failed. I don't think so that is there, but I think I can demo if we have time. So let me make a note of that, that you want to learn that. If we don't have this as a part of the course, then I'll cover it if we have time. Okay? No problem. You can always give me a request if we have enough time. I'll surely demo. You have seen that I'm already doing more than the content what is given in the book because I want to make sure that you have good experience of the trainings and the content and the product. No problem. I have made a note of this, and if we have time, I'll make sure that we do. In the course officially, I think we only have one page where we are just talking about it, but I don't think so that we have anywhere where we are actually doing a demo practically. Okay, so I'll try my best to push it somewhere in the middle of the chapters so that it will become much easier for you to understand. Would that work? Great. I think we do have enough time, more than enough time actually, to cover block rescue always. So maybe I'll do it today in the evening, late evening, before we end our session. But if not today, then tomorrow morning for sure. I think we have enough time. Okay. Any other questions or requests, guys?
Nope, not as of
Okay.
now.
Thank you so much, guys, for that. For the reply, at least, there we go. So these are all the types of conditions that we have. But also one more thing is there that we can implement multiple conditions at the same time. Now, to implement multiple conditions at the same time, there are two keywords. There is an and keyword and then there is a or keyword. And means both the conditions which you're defining must be true. And or means only one of them. If it is true, then it will run the job. So to define a condition based on and, it's damn easy. Simply define a condition like this. Define and now define the other condition. For example, if IP is defined. Done. So there are two conditions now which Ansible has to evaluate in order to get the true or false. The benefit is and can be defined in another format. There is another format to define and based conditions, which is in a list format. So if you define all the and based conditions in a list format, this will also become and. So if you define multiple conditions in a single simple list, that becomes this condition and this condition. And this will still work. There you go. Now talking about or condition, or base condition. The only way to define OR based condition is this. Put the keyword up in between. There is no other way. So either the left condition should be true or the right condition should be true. Even if one of those is true, Ansible will simply run. So there we go. And you can see the task is running. Does this make sense?
Yep.
Great. So guys, this is how we can define all the different types of conditionals which are there and multiple conditions. Now let's talk about implementing loops. Like how can we run the same task in an iteration form? So let's say if I want to ping multiple IPs, how can I do that? Right? So by default, we can only ping one IP at a time because that's what the module supports to us. If I want to ping multiple IP, I cannot define it in a form of a list. The module wouldn't support that. And when we want to ping multiple IP means run the same task multiple times, the thing which we can do is implement loops. So loops can be implemented for one purpose, and that is that when you want to execute the same task multiple times just by changing the final value, that's where you can run loops. If the module doesn't support the data in a list, you can use loops. For example, if I want to implement loop, what I would do is I will define a specific keyword in the destination over here, which is item. It is a predefined keyword, remember. And then we will use the loop keyword as a task level option. So remember, whatever you want to ping, rather than defining it manually, you are telling that get it as an item. An item variable is a predefined variable for Ansible, which you should not define anywhere else. And it only reads the value from the keyword loop. And now you can define multiple IP addresses which you want to ping. Like this. So Ansible will go ahead and ping all the IP addresses in an iteration form inside a single task. See, 1, 2, and 3, all IPs has been pinged this way. Does this make sense, guys? What is a basic loop here?
Yeah.
Now, you can have, so Ansible does have a lot of different types of loops. There is a nested loop, there is a dictionary loop, there is a random loop. So a lot of different types of loops are there. Overall, if you really talk about, I remember that there are around 10 plus types of different loops available. Okay. So let me show you a demo of a complex loop, which is a nested loop here this time. To implement a nested loop, we will not use a loop keyword here. We will use an older style keyword. So back in the days before Ansible 2.5, means until Ansible 2.4, the loop keyword was not there. So loop keyword was only introduced in Ansible 2.5. Before the loop keyword, we were having with underscore as a prefix and then lookup plugin name. So for a nested loop, the lookup plugin name was nested, where you can create a nested list. For example, ETH0 and ETH1. This is a first nested list, means a list inside a list. And then you can create another list over here. Let's say 172.25.250.9, 172.25.250.8, 172.25.250.254. And now you can ping them or do any other job if you want. Let's say I want to run a command. I will do it on YOS this time. YOS underscore command. Here I will define the commands which I want to run. And I remember why it failed before, why it was not running, because it's a Linux machine where ping always runs continuously for forever. So we had to define the actual time. So this is going to be spine01 where the task will run. And the command which I want to run is ping. Now the destination IP I have to define. The destination IP is defined in the second list over here. Okay, this is the first list, this is the second list. So to define a second list, it is simple. Item dot zero. Sorry, item dot one. So the first list is on the 0th index, the second list is on the first index. Okay, so that is item dot one here. And then from which interface? That is from the item dot 0th interface, and then just count 1. Okay, so the way it will be explored is like this is the outer loop, and then this is the inner loop. Remember, inner loops always runs fast. So let me run it and let me show you the entire output over here. Now, remember, we do have to wait for a few minutes because, it's a iOS device, runs a little slower than the other. Okay, it's much faster right now. Okay, I think that is just the Spine1 device right now, which is just running the first from ETH0 interface. Now it will run the ping again for the same interface from ETH, what do we call this? 1 interface now. So we'll just wait for a minute. There we go. As you can see, it is still running. So give it a minute. And guys, so you can notice right now, the task has executed successfully. Let's try to extract the content from here and understand from the output. This is what we call a nested loop because we are implementing it from a nested list. This is a list, and this list stores the data in form of another list, and another list which stores the data in form of another list. So take a look. Remember, whenever we talk about a list stores the data on the indexes. Index number starts always from 0, then 1, then 2, and so on. So when I said ping, go to the item which will talk to with nested, and I said 1, that means go to the first index. Remember, the first data is on 0th index, the second data is on this index. So first time in the first iteration it will talk to 250.9, in the second iteration 250.8, in the third iteration 250.254. From the interface for the first time, ETH0. Okay, so this is the inner loop. Sorry, this is the outer loop, and this is the inner loop over here. Inner loops always runs faster. And count 1. Only one ping it has to do. So you see, from ETH0, it is pinging all 3 IPs. And once this is over to ping all 3, then it is going to item.0's second interface and going to ping all the 3 interfaces once again. Does this make any sense that how this kind of a nested loop works?
What happens if we change the item number 1 and 0, vice versa?
That's a great question, and let me show it for you. So if you move this above, you do have to change this. So now this becomes 0, and this becomes 1 because we still have to define the interfaces correctly. Now the result will be a little different, and you will notice that. So let's wait for the result to come out. Authentication failed. Okay. Oh, okay. I have defined the wrong password. This is the right password. Let's wait for a minute now. As you can see, guys, the output is a little bit different this time. And let's try to understand how it is a little different now. Because this time the inner loop and outer loop has changed. This one has become the outer one and this one has become the inner one. Inner always runs faster. Means once I go to this IP, I have to ping it from both the interfaces. This. Then I have to go to the second IP and ping that from both the interfaces. You might notice this over here. And then I go to the third IP address and then I ping it from both the interfaces. You might notice this over here. Comparing to the previous output, where first interface will ping all three, then second interface will ping all three. Does this make any difference? Does it make some sense, guys?
Yes.
Okay. So I hope a nested loop is understandable by now. If you have any confusions, please fire questions.
Can I know what does that U means?
U is just a Unicode information.
Okay.
You can ignore that. That is just a way Ansible shows you the output that this is the Unicode information. That's all. So if you remember, what happens is Ansible runs everything behind the scene in Python, and it has to convert the data in JSON to show it, because that's what Ansible's job is. It will always convert the output in JSON. So that's why it's called a Unicode information. Make sense?
Yep.
Any other questions, guys?
Rajat,
Mm-hmm.
when you are running this, you can see that the task pinging a host you are running, right?
Sorry,
I'm talking
when
about,
I'm running this?
yeah, your task. So basically, the output of the task pinging a host. Can you see? Okay, there is,
Yes,
6 lines. So
exactly.
basically, is there a way that we can hide this log output?
We can actually. Again, this is not in your book, so if you want to make a note, please do. The way is we can implement a keyword called no log to be true. No log true allows you to not log any output on the CLI, and it will now report item equals to none. When you rerun this. There we go. Let's wait for a minute for it to finish.
Okay, so it will still print, I mean, each line.
It will. But that's how the iteration is working, right? You can't
Yeah.
remove the iteration execution. That's what we call a loop, right?
Okay, okay. So
You
I
can
mean, iteration print will be there, but item we can paste it as none.
exactly means if your data which Ansible is printing has some confidential information in it, then you can define no log true and Ansible will not print it anymore on the screen. If you
Okay,
remember, in a production environment, sometimes what happens is you create the playbooks, but somebody else runs it, right? And you don't
exactly.
want them to see the output information. So
Yeah,
in a production environment, to hide that information, we use no log true, so people can still run it, and we don't have to worry about them knowing the confidential part of our execution.
yeah, yeah.
But iteration print will always be there because that's iteration execution. If Ansible doesn't even report that it is iterating, how would you really know?
Okay,
Again, remember this is not in your book, so make a note if you want. I'm going to cat the playbook for you. You can make a note of no log, which is a task level keyword. Any other questions so far, guys? Okay, so as there are no further questions, let's go further then. Now, the next thing what we are going to do is we are going to see something from the slide for another type of a loop here. Let's see if we have, so I have explained the simple conditions, compound conditions, like, multiple conditions. And now if you'll really see that they have very less information here. Programmatic style, where you can simply implement the task over here. We've discussed all of that. We have discussed about, we just discussed about loop, with nested. As I said, there are other loops as well. They have just listed 2 of them, but there are more than 10, which you might be able to find. We have seen an example of a simple loop. We have seen an example of a similar example is right here in your books as well, the one which I created, but it is using some extra variables. I did not create this complex. I just defined the values like this over here directly. Okay, yeah, we have one more thing, which is over dictionary values. You can do that as well. So let's say with iOS facts, you gather every single thing when your device is iOS, and from the target host, Gigabit Ethernet 4, you want to print some information. So what do you want to print? With dictionary from Ansible Net interfaces. Now, if you remember, Ansible Net interfaces is having the information about interfaces. So if your item.key is the target underscore interface, which is Gigabit Ethernet 4, and if that interface is having the value operational status as app, print this message, whatever we are printing with item over here. That is the interface information. So you can create complex loops like this as well. Depending on how your data is, you can create n number of conditions and loops to implement them. Does this make sense, guys?
If we have to gather all the facts, what is the significance of adding gather subset all?
So gather subset all also gathers the running, what do we say? Running configuration information. You know, the current configuration which is there on the device, it also
Oh,
gathers
yeah,
that.
yeah, 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 you mentioned
But
about,
we don't
yes.
really need that at all because we can't use that anywhere, right?
True.
So it is just for the demonstration purpose that what it gathers by default and what else can you gather defining the subset. It's not just about
Makes
all.
sense.
You can limit the gathering as well, right? That I only want to gather only this much, right? So let's say I only want to gather interface. So you can do that.
Yep.
And this way the output will show up for Gigabit Ethernet 4 if the host, if the interface is up. Okay, now let me show you by failing a task and then let me show you how you can make it better. Oops. There we go. Let's keep it pretty simple right now. Let's think 172.25.250.9. Let me just run a normal playbook for a minute. There we go. So a normal playbook simply runs. Now what I want is, I want that if this task runs successfully, another task runs and says a good task. And it should just print a simple message. This is a good task. There we go. Okay, both tasks are running. Now, what if the first task fails because of any reason? Let's say I want to ping the IP address 90, which doesn't really exist. What will Ansible show us? Ansible has given the command on the YOS. It's trying to run, but it cannot run because there is no IP address called 90 in the network right now. So Ansible ran a command. It ran on the host. It couldn't ping it, but Ansible doesn't throw us an error. Can anybody tell me why?
This task was successfully completed anyway. We were not checking
Exactly.
whether ping is successful or not.
Exactly. Now, but if you put a -v, it will show you what happened. Let's wait for a minute for this to come back. So before it goes ahead and shows you the result, let me tell you, Ansible is still transmitting packets, but Ansible will receive 100% failure. Okay, sorry, 100% not reachable packets because the host doesn't exist. So if you see the task got executed successfully and the error is destination host unreachable. For Ansible, this is not an error because Ansible still was able to run the task successfully. Let's try to fail this task then. Can somebody tell me if this is the correct format of an IP address?
Yeah.
This is the correct format of an IP address?
Oh, sorry. Screen refresh. Little slow. No, this is not right.
Exactly. So should Ansible be able to ping it? this time?
Should fail.
For Ansible, will not. For the host where it is running, it is failing, right? The network is unreachable. You have defined a wrong network address or whatever address you have defined. But for Ansible, the task was given to the host successfully. To now actually fail it, I will do one thing. I will make the command wrong. I will just define pin instead of ping. Now this is a wrong command and Ansible cannot give this successfully to the device. Again, this time IP address is correct, but I just gave pin.
Auto complete.
Make
Yeah.
PNG instead of pin.
Yeah, that's the way I can do it. Let's make it PNG. Now it cannot autocomplete. And there we go. So the task is failing, and because that task is failing, the next task is not even running. Whenever this kind of a situation happens, and you are kind of sure, okay, that if I continue, this will not affect my execution, you have a keyword which is called ignore errors. So, means if any error occurs anywhere in the play, ignore that and move on to the next task. Time, Ansible will run successfully because the error came and we ignored it. And then Ansible was able to successfully continue with the next task execution. Does this make any sense?
Yes.
Now, this option can be defined on the play level the way I have defined it, but this option can also be defined on a task level, right here. Ignore errors. Okay, so if you define on a play level, let's say if there are 20 errors, it will ignore all 20. If you define on a task level, then it will only ignore the task particular error which there is.
So we should define that on a task where we want to ignore error, or we should define it on a task which we want to run even though there is an error. So right now, for example, you are putting it under ping task. So what does that mean is even if there is an error in the ping task, it will perform following tasks, right?
Mm-hmm.
So
let me give you an answer very straightforward. The answer to your question is, it depends on the situation. There is no expected answer here. So let's say sometimes you don't know if error will show up, but you want to continue that even if error shows up, you continue with the execution. That's where you define ignore errors on the play level. Okay? You don't care about the error, you just want to continue. Make sense?
yes.
But this is one scenario. But sometimes you are kind of sure that if I run this task, it will throw an error if something is wrong with the host, connectivity is broken, or something like that. If it is broken and if you want to ignore it, you can do that as well. Then you have to define on a task when you are expecting it might end up failing this particular task.
Okay. So we are putting
in a production
it under the
environment,
task. So we
it
are
will
putting it
only
under
ignore
the
the
task where we expect an error to occur.
expect an error to come.
Okay.
In a
makes sense.
production environment, we recommend our customers to extensively test the playbook they have written. Okay? Expect that errors will come, and with that expectation, define ignore errors as well. Okay? But there is no predefined straightforward answer that here you should define, here you should not. It completely depends on the infrastructure and the customer's error handling scenarios as per the policies. Thus, some customer says error occurs, you stop the execution, and the ad should send an email to the administrator, and it's job of administrators to come and check what went wrong before we move forward. Some says if error comes, let it be. We'll resolve it further later, but in the meantime, continue the remaining playbook so we can see how it is affecting our infrastructure. right? So it completely depends on organization, people, and the scenarios which you're deploying right now. Does this explanation make sense, guys?
Yep.
Okay. Any questions so far then? I'll take that as a no. So, guys, the next thing which we have to do is guided exercise over here, controlling tasks with loops and conditionals. Let me put it on the screen that which page number and everything it is, then I'll show you by doing it and then you do it. Remember, I'll show you the whole guided exercise first, so please watch me doing it, understand it, and then you can perform it. I'll give you guys enough time to perform it. This guided exercise is on the page number 101 with a total duration of 15 minutes. Let me show you this first now. Okay. So first, it is asking you to create a playbook, iOS Ping 6. Rather than creating it, we will download it. So iOS Ping 6.yml. And we will review it. Remember, after downloading, because we have not written it, it's always good to review it. So it has defined some variables, interesting destination in a format of a list. We are trying to ping it to the destination and we are looping it. And see, loop is defined, the list is defined over there. So to run it, iOS ping 6.yaml. Password for the CS01 is student. Once I've defined it, and you can see it is running in a loop format and pinging both the IP addresses. Now, second, which we'll be doing is multi-vendor syscheck2.yml. So multi-vendor syscheck2.yaml. Now let's review this. It should run on the network, means all Cisco, iOS, and iOS. Now we know that a task cannot run on all the hosts, right? Because modules are different. So when you run on iOS to take the backup, a condition is there that when the OS is iOS, then only run this. So see, because on the basis of a condition, it is able to make that effect to run only on iOS. Then again, run iOS following commands only on the iOS host. It is also registering the output of this. Again, take the backup of iOS, only run when the host OS is iOS. Run the following commands on iOS. Again, store the result in the memory and only run on iOS. And then print the result. Now, to print the result, we are using item because we have multiple OSs from where the result is coming. But you will see that we are using a combine functionality to combine the results of iOS and iOS to print in a single task rather than running it in a separate set of tasks. So if I do multi-vendor syscheck2.yaml, I think I still have to define the password somehow. So I think we have to, yeah, but I can also limit the execution, right? As per the guided exercise, we have to limit the execution first on iOS. C01, so that is the student. As you can see, iOS part did not even run. iOS part is running and it is showing you the results of the iOS tasks. Okay. If you do it on iOS, maybe on a single host or maybe on the whole group, let's say iOS, the password is iOS and it will print results for all 4 hosts per year. See this? The results are very big because it is for all the hosts. First, it is for leaf02 from here till here. Then, okay, here as well. Then it is for spine01. Then it is for leaf01. And then it is for spine01. And more results. Make sense?
Yeah.
If you download the playbook and run it, though it will not take 15 minutes, but yeah, I'm ready to give that much so that you can understand and run it. Running a 15 minutes timer, let's get started. and then I'll take all the questions.